All right, so we are talking about the domain of a function. So whenever you are finding the domain of a function, you must watch out for these two things. Number one, when we have fraction, that means when we have a rational function, we have a function there over another one. Okay, when we have a rational function, and then number two, you must watch out for when we have a root. When we have a root, okay, something like this. Yeah, you must watch out for those two. Okay, in number one, when we have a fraction, don't forget that we don't want the denominator to be 0. So whenever you want to find a domain and we have a rational function, you must make sure to find where the denominator will be 0 and to avoid it. Okay, for example, if I say this equals to this, okay, so you will see, of course, this can be written this way. That can be written this way. If you divide by x, you can have minus 1 over x. Okay, that can be written that way. Okay, but you will still have to deal with this division by x. Okay, so we don't want the denominator to be 0. So now, looking at this, what value of x will make this to be 0? Of course, it's 0. So when x is 0, this function will be undefined. So we need to avoid 0. So that means the domain of this function is negative infinity to 0, union 0 to positive infinity. All what we are doing here is to avoid 0. Okay, because 0 will make this function to be undefined. Sometimes the function we are given is like this. Let's say we have something like this. Okay, so you will see again, we don't want the denominator to be 0. So that means x minus 1 must not be equals to 0. By the time we solve this, then we get x equals to 1, which means we cannot have x equals to 1. Because by the time x is 1 here, it makes the denominator to be 0. So we don't want x equals to 1. So that means the domain of this function is negative infinity to 1, union 1, infinity. Okay, so we're just avoiding the denominator to be 0. That is the first part. The second one is when we have roots there. Okay, when we have root, in the root, we don't want a negative inside the root. We don't want a negative inside the root. So if we have a function like this, we don't want what is inside the root to be negative. So we write the domain of this function will be when this is greater or equals to 0. That is the domain of it. We don't want a negative inside the root. When there's a negative inside the root, then that gives us a complex number, so we are no more in real number anymore. Okay, so but we are dealing with real number at your level or in this module. Okay, so we want x minus 1 to be greater than 0. Then we can solve for this, then we have s greater or equals to 1. Okay, so the domain of this function is 1 to infinity, but because of this equal sign, then there is a square bracket here because 1 is included. When we put square bracket, we mean 1 is part of the domain. So 1 is included there. So it's from 1 to positive infinity. So you watch out for these two things whenever you are asked to find the domain. If there is no restriction, if there is no any restriction on x, then the domain of that function will be negative infinity to positive infinity. Then that will be the domain, if there is no any restriction on x. Okay, please make sure you take note of that.